In this project, we'll be going to see about that how to chat with your own document with the help of this RAG technique. RAG is actually Retrieval-Augmented Generation. What is actually retrieval here? Retrieval, which is used to fetch the information from documents like docs and then PDF and then etc. And the next one is augmented. Augmented here refers to enhancing input query to the large language model. Large language model is all about transformer kinds of model like Pi2, Pi3, Pi3.5, then meta kinds of model like LLama 1, LLama 2, LLama 3, LLama 3.5, and then Mistral kinds of model. These are all the most real models we are using in the RAG technique with an external knowledge that is actually retrieved from your document store or databases. And the next one is generation. Generation is all about generating text data based on user query. These are all the small information about RAG full form, especially in the ChatGPT version 3 and 3.5. They were actually not included, these kinds of feature. In the ChatGPT 3 version, which it can be able to generate a new data based on user query, but in the ChatGPT 4 version, they were included PDF upload or upload any kinds of document, then it can be able to answer from the document. Along with this, it can be also communicate with internet data like GitHub, Google, and the Stack Overflow, YouTube, and then any kinds of open source website. RAG is actually one of the amazing technique which is also communicate with your own data, then your information will be prioritized by this RAG technique. Let us see how to implement this RAG technique with the help of BGE and then FAISS and then Phi-2 Microsoft model. So let's get started to implement the RAG technique with these kinds of methodologies such as the BGE, FAISS, and then Phi-2 R2.2. The project title is all about chat with your PDF using BGE and then FAISS. Later we'll be going to see about that what is BGE and then what is FAISS. Next we'll be going to see about that quick look into project objective. To build a system where users can upload a PDF or any kinds of document, ask questions about its contents, with the response generated using a lightweight language model like Phi-2, and then semantically rich vector search using BGE small n v1.5 embeddings method and then FAISS. These are all the methodology we'll be going to use in this project to develop a RAG project. And the next one is all about core components of the project. Then first one is all about PDF boxing. What is actually PDF boxing? PDF boxing is one of the Python library. This library, which is used to extract text from the uploaded PDF using library like PIMDF and then PDF Miner and then PDF Plumber. These are all the Python library which is used to extract the content from any kinds of document like PDF and then docs. And the next one is all about embedding. Already you know what is embedding. Embedding is a methodology which is used to convert text into numerical. Numerical is all about that high-dimensional vector space. This high-dimensional vector space, which is used to understand by the large language model, then it can be able to identify the relationship between the words in the sentence. And then we'll be going to use here pre-trained and embedding model that is actually BGE small n v1.5. This model actually developed by the Hugging Face open source community. This actually open source model so all can use to develop RAG technique and then which is used to convert text to numerical and then which was actually trained by the vast amount of English content and then which is used to convert text to numerical into dense vector embeddings. The numerical is all about dense vector embeddings and the next one is vector search. Vector search which is used to compare two different embeddings data, then how much which is similar these two embeddings data. After converting text into embedding data with the help of BGE small n v1.5 model, finally we'll be going to store our embedding data to FAISS vector database. Store the embeddings in a FAISS index. Embeddings will be considered as a one index. And the next one is on user query. This is all about user input data. Embed the questions using same BGE model, then perform a similarity search using FAISS to retrieve the most relevant answer from PDF chunks. The data will be as chunk data. LLM-based answering like Phi-2, which is used to communicate with the FAISS index, use the Phi-2 language model to generate a natural language answer like English based on retrieved context. And then core component has been displayed in a table format. First, we need to import a table from our table. This is all about text exclusively, which is actually in list data type. This actually first lists text extraction using PyMuDef and then PDF Plumber, and then embedding conversion, embeddings BGE small NV 1.5 model, and then vector source using FAISS vector database, and then we'll be going to use Phi-2 language model. This is actually vision language model, and then backend API will be going to use Flask and Ngirok. The tabular output will be like this, such as component is first column and then tool is second column. And the next one is we'll be going to see about that small information about BGE model. This one is actually named BGE small ENV 1.5 model, who is developed actually BAI, which is actually stands for Beijing Academy of Artificial Intelligence. What is the use of this? Sentence and then text embedding. This actually English only supports, and then model size is actually 110 million parameters. If you give any sentence to this BGE small ENV 1.5 model, then the output will be 384 embedding dimension. 384 data will be present in the embedding output. And the next one is performance. This is actually lightweight but effective. Effective, which means high dimensional vector space, then ideal for semantic search. What is the relationship between the sentence in your word? This all about semantic search. Then next one is RAG use cases. And the next one is prompting. Use query, your question for question, passage and text for documents. And the next one is input type, short and long text sequence optimized for retrieval task. Retrieval is all about retrieval-augmented generation. And the next one is all about that use cases. RAG kinds of application, then semantic search, and then FAQ, frequently asked question matching, and then documents similarity. And the next one is the framework. Framework like compatible with sentence transformers and then Hugging Face transformers. It can be export as some format like ONNX and the torch script, and then FP16 floating point 16 for inference optimization. Licenses all about Apache 2.0, then release date is 2023 December. This is all about Hugging Face repository link. http:// and then // then huggingface.co BGE small env 1.5. This is all about Hugging Face, our name, and then GitHub repository. Next, we'll be going to see about that small information about BGE small env 1.5 language model. BGE small env 1.5 is a compact which is all about lightweight, high performance sentence embedding text into numerical conversion process that is actually high dimensional vector space. Developed by Beijing Academy of Artificial Intelligence, BAI, it is part of the BGE, Big General Embedding, is a family and then designed at full specifically for retrieval augmentation generation, the semantic search applications. This is actually small version that is actually optimized for speed up. It can be able to get a response quickly, and then resource utilization. Resource utilization is all about small memory will be used like CPU or the GPU while still delivering competitive performance in embedding tasks. And then next we'll be going to see about that small architecture information about BGE small ENV 1.5 model. This is actually built based on a BERT model. Distill it better is all about modification of BERT architecture. Already you know what is BERT. BERT is actually bidirectional encoder representation of transformer which contains only encoder network. There is no decoder will be there in this BERT architecture. BERT is actually developed by the Google. Then every layers will be multiplied from input layer to output layer. Then finally, we'll be going to get approximately 110 million parameters. Parameters is all about weight and bias and then making it significantly lighter than standard BERT-based models. The model takes a sentence or a chunk of text as input data, output a 384-dimensional dense vector that captures semantic meaning of the text, unlike traditional BERT models which are primarily used for token-level classification and then text generation tasks. BGE is actually tuned specifically for sentence-level embeddings. This is achieved through specialized training objectives and then pooling strategies. Then the architecture uses transformer encoders like BERT were used to develop this BGE small ENV 1.5 model. And the next one is a mean pooling mechanism over the token embedding. Token embedding is all about individual word embedding in your sentence. And then finally generate a single vector. Vector is all about that. This actually let us consider this is actually one set of sentence, then convert into single vector. This is actually all about single vector, which will be their numerical data like 0, 0.1 and then 0, 0, 0.9. A lighted value will be present in the single vector. This is actually high dimensional vector space. And the next one is an optimized structure to balance speed and then semantic performance. Next, we'll be going to see about that small information about training strategy of this BGE 1.5 EN model and then datasets information. The BGE small ENV 1.5 model is trained at using contrastive learning approach. This is actually one of the approach were used in the BGE ENV 1.5 model, a method where the model learns to bring similar sentence in the documents or text closer in the embedding space while pushing dissimilar ones apart. It will throw out the dissimilar part in the document. This is ideal for tasks such as similarity search and then clustering the sentence and then dense retrieval. Next, we'll be going to see about that what kind of dataset were used to train BGE ENV 1.5 model. BGE models, including this one, were trained on a large-scale corpus. Corpus is all about text data, combining both public and curated datasets, while the exact dataset are not all publicly listed in fine detail. The following types of data are commonly included to train this BGE ENV 1.5 model. The datasets are MS Marco, large dataset used for training retrieval models containing real-world query passage pair. And the next one is natural question, a dataset for real question and the corresponding answer from Wikipedia website. And the next one is a multi-NLI and SNLI dataset used for semantic alignment and understanding. And the next one is public QA question and answering pairs are then crawled and filtered content to improve generalization across diverse question and answer scenarios. In the case of BGE small ENV 1.5 model was trained using 8.8 loss and pairwise contrastive loss, and then with the labeled pass like query positive passage and then query negative passage to refine the embedding space. Finally, we'll be going to make inference using FlashContNGG first. We need to install a FL-NGRG configuration and then we need to install NGRAG and then Flask. And now we need to get authentication token from official NAG website. Next, this is actually a small part of HTML code which is used to build a front end which is also similar to PH-NumPy sentence transformer. You need to import this is library and then sentence transformer, auto token assessor, auto model 4, Cashflow LM, and then this is actually upload folder which is used to upload your document inside uploads folder. Allow to document this txt pdf and then docs. This actually will ask initialization. This is actually a security purpose. Set a secret key, then app folder, and the next one is a 56. Index is actually none and then chunks is actually empty list. This actually allowed file. Then we need to access a 5, this index, the chunks inside the function, and then this actually prediction is actually initially none and then question is actually none. Chat is say actually initially none and then section do get a charter string. If the method is actually post to is actually which is supposed to send the data, then we'll be going to get a file name requested files kit which is used to access path or request in form format like a.txt if upload a file and then allow it a file that secure phylum OS path. Gin, this is actually folder name which contains files inside the folder app. Do config upload folder, then upload file, save then extra PDF and then chunu text on, then phis index on, then j chunk text on the phis index posting if it is there 3 of these. Next, we'll be going to call a retrieve chunks function with, and we will be going to feed our coing ph index and chunk text. Finally, we'll be going to generate answer using Phi-2 model. We need to feed question and relevant chunks and then final answer, and then we will be going to append this answer to chat history question and the final answer. This is all about chart history. Finally, we'll be going to return index HTML render template, which is used to load index HTML file. And this is all about input question. And this is actually model prediction and then chart history. And then I do run with the port 5000. And the next I'll be going to execute the code one by one, especially particular cell. First, I will be going to execute this. In the first step, we need to connect with the Google Colab notebook. It is essential that the internet connection is active and stable with this because the entire process is running based on a cloud page. Subsequently, we will be going to the runtime environment and change the runtime settings to the default GPU. After that, I will proceed to execute this particular set of code. The next crucial step involves installing the flag embedding library and then the sentence transformers library. Now it was successfully installed, flag embedding library as well as sentence transformers library. Next, we will be going to get output of text into embedding vector using BG small ENV 1.5 model, and then we'll be going to get a 384 embedding output. This is actually the output of the embedding process, and then the embedding size is actually 384. Next, we will be going to execute this particular cell. Following that, we will proceed to execute this cell. And the next one is the PRS install for our CPU. Subsequently, we will be going to execute this section. The top matches indicate that Paris is indeed the capital of France, and its score is actually 0.8. Furthermore, machine learning has a score of 0.47. And then cats are great pets in the index plot IP. The score will be lower, meaning that iron will be more similar, and a lower score will indicate less similarity. The next we will be going to see example with the Euclid distance for B is small in V1.5 model equivalent distance. The score will be here. Paris is the capital of BRH. This is actually I similar, the score is actually very small, and then I score will be less similar. Next, we will proceed to execute this particular cell, and subsequently, we will then execute the following cell. After that, we will be going to download the Microsoft Phi-2 model. Please be aware that this download process will likely take a considerable amount of time to complete, primarily due to the large file size of 564 megabytes, even with a 5G connection. Now, the Phi-2 model was successfully downloaded from Agging Fish repository. Next, we will proceed to the EC Good component, which is another system developed by SI and utilizes Phi-2. This EC Good serves as the actual input query. Following this, the next step in our workflow involves moving to the context phase. This particular context is designated as the prompt initial, where our initial instructions are established. Subsequently, we will transition into the tokenicism stage, where the input is broken down into individual tokens for processing. After tokenization, the model will then generate output, which means it will produce the desired response. This generated output is essentially the generate text phase. The generated text then undergoes a process where it tokenizes again, and then it is decoded to be presented in a human readable format. This entire process is facilitated by Anna Microsoft. Moving forward, I will now execute this specific cell in our environment, and then immediately after that, I will also execute this subsequent cell as well, ensuring the complete flow of operations.
And this particular one, this one is designed to build a robust and efficient FAISS index, and then subsequently retrieve relevant information chunks from it.
And then we will proceed to generate the answer. Following that, we will be going to meticulously upload PDF documents within the confines of this Google Colab notebook environment. Subsequently, I will be going to carefully choose the necessary files from my local disks downloads folder. More specifically, I will be going to select the Transformers Architecture PDF document. Then I will proceed to open it now, which is currently uploading with a visible percentage indicator. The last modification date for this file is recorded as 25/2025. This particular file actually represents a substantial amount of data, specifically an application PDF. Now I can confirm that the PDF document was successfully uploaded onto the Google Colab notebook, ready for further processing and analysis. The folder is actually Data Transformer Architecture PDF, and the next we will be going to part check a public working directory. Working is actually content, and then from Yoti import pash we will be going to access PDF files prompt folder. This is actually an input query, then extract PDF text, then chunk text, and then build files is read chunks, generate answer. Finally, we go to getting final answer. This is actually final answer. Transformers are a type of neural network architecture that is used for a natural language processing task. They are based on idea of attention, which allows the model to focus on different points of the input sequence when making predictions. Transformers have been shown to be very effective for tasks such as language translation, text summarization, and then question answers in. They also used in other areas such as computer vision and video processing tasks. Next, I will be going to change my query into what is
Attention.
which is actually processing input queryum. This is actually final answer. Attention is a mechanism that allows a model to focus specific parts of the input when making predictions. It is used different types of models including neural network to improve the performance. In the broader context of neural networks, attention is specifically used to help the model precisely focus on different relevant parts of the input data when making a prediction. Next, I will be going to explain in detail what multi-head attention is, and then I will be going to execute multi-head attention, demonstrating its practical application. Attention is a technique in the trans-on model help the model understand complex relationship and patterns in the data. It is actually responsible for helping the model to learn more complex pattern and relationships in the data. Next, I will be going to ask another set of query, which is actually what is encoder, which is actually processing input. Query encoder is a module in the TSS-on architecture that takes the input sequence, process it through multiple layers of self-attention, and then feed forward a neural network. It also applies position encoding to the input sequence to capture the order of the elements. The output of the ENC encoder is then passed through final layers of normalization to produce the final output. Next, we will be going to model inference using Flask Content Arch. First, I will be going to install Ngerog. Next, I will be proceeding to obtain the necessary ngrok authentication token. You can find this token by navigating to the official ngrok.com website. Once you are on the ngrok website, you will need to log into your account. After successfully logging in, locate your unique authentication token. It is crucial to carefully copy this entire token. Subsequently, I will be replacing the currently existing authentication token with this newly acquired one to ensure proper functionality and connectivity. Next, I will be proceeding with the installation of Python, specifically py, within the environment of Rock. Following the successful installation of Python, I will then proceed to install Flask, which is a microweb framework also within the Rock environment. After the installation of Flask, it will be crucial to meticulously set up the necessary authentication mechanisms to ensure secure access and operation. Subsequently, I would then move on to creating a brand new folder, which I will name templates, as this folder will serve as the designated location for our HTML template files. After the creation of the templates folder, I would then be going to create a specific file inside it, which will be named index.html. This index.html file will contain the main structure and content of our web page. Once the index.html file is created and opened, I am then going to perform a series of actions. First, I will press Ctrl and Alt simultaneously, followed by pressing Ctrl again, which will allow me to copy a predefined set of code. This code will be essential for the functionality of our web application. After successfully copying the code, I will then proceed to paste it directly into the index.html file. Once the code has been pasted, I will finally save the changes made to the file and then close the file. In the next phase, we are going to execute this particular cell, ensuring that its operations are carried out as intended. Furthermore, we will also execute this other cell, which is equally important for the overall process. We will also ensure that this specific bond is activated and functioning correctly. And finally, we will close all relevant windows and processes once all tasks are completed. Next, I will be going to carefully click on this particular URL. Next, I will be going to diligently visit the specified site. Next, I will be going to meticulously choose the file named 5 from the local disk, specifically the transhumor architecture PDF document. The very next step we will be going to ask about is what exactly is
Transformers.
Then we proceed to submit, which is actually processing our input query. The input query was submitted using the Flask framework's post method. We then extract the textual content from the PDF document, subsequently chunk the extracted text into manageable segments, build comprehensive file indexes, retrieve the most relevant 11 chunks, and finally generate an answer using the Phi-2 model. What is transformers? Transfer is a type of neural litator architecture that is for natural language processing tasks. It's based on idea of self-attention. Next, I will be going to type here another set of query here, which is actually what is attention. Next, I will be going to choose CSC same PDF file in, then I will be going to submit. Now the next query answer is given by the Phi-2 model. What is attention? Attention is a mechanism that allows your model to focus on specific parts of the input when making predictions. It is used in many different types of models, including Neon Network, to improve their performance in the contraction Neon Network attention user to help the model focus on important parts of the input when making prediction. Something you should have learned from this Array-C technique project. Suppose if you have any tones regarding the project, code, explanation of the project, and code execution of the project, let's put your thoughts in the comment section. I'm ready to clarify your doubts. Thank you. If you want to use BGE small NV 1.5 model, then we need to install a flag embedding as well as C sentence transformers. And then next we'll be going to see about that. What is actually embedding? Embeddings are dense numerical representation of data, which means text to convert into a numerical process such as words, sentence, or image. Image also can be converted into a high dimensional vector dimension using clip kinds of model that capture the meaning of features in a format that the machines can understand easily. And they're not like one-hot encoding. One-hot encoding is also converting to text to numerical, but there is actually complex of using this one-hot encoding, and there is no high dimensional vector space will be there in the one-hot encoding, so it cannot be understood by the any kinds of machine learning kinds of model, deep learning, NLP, and then generative kinds of model. And then unlike one-hot encoding and sparse vectors, embedding a transformed input into low dimension. Low dimension is all about high level features that is actually extracted from pre-trained model like a BGE kinds of model, BERT kinds of model. Finally, the vector, which is going to be like this, continuous vectors, that is actually preserve semantic relationship between in a sentence. For example, in a word embedding space, the vector for king and queen, there is actually some relation between these two words such as king and queen, so it would be closer together. Then it will allocate more score for this queen. The score will be like a 0.9, 91, 92, or 95. Then king and banana. There is actually no relationship between these two words such as king and banana. So it will allocate only low score for this banana like a 0.1, 0.05 and a 0.20, 30. Like that score will be allocated for these banana words. These vectors are learned during model training technique like word-to-vec BERT and then sentence transformer kinds of model. Embeddings allow models to generalize better, enabling them to understand contextually in the sentence, and then similarity, and then relationship between inputs. In NLP, sentence embedding like from BGE small NV 1.5 are used for tasks like search, similarity search, and then clustering, and then classification kinds of tasks. And then computer vision image embedding help recognize similar images or objects. Embeddings are also essential in retrieval-augmented generation recommender system where fast similarity search is required. And then they make unstructured data like text or images compatible with vector-based mathematical operation. Embeddings essentially form the bridge between human-like understanding. Human-like understanding is all about all kinds of language like English, Spanish, and then French, Italy, and then etc. And mathematical computation AI system, any kinds of machine learning model, deep learning kinds of model, NLP kinds of model, generative kinds of model like a transformer, BERT, and then GPT, and then etc. And then next we'll be going to import a sentence transformer from a sentence transformer. This is actually one of the Hugging Face library, which is used to initialization of any kinds of pre-trained model, and then we'll be going to use by the BGE small NV115. This is actually Hugging Face repository name. This one is actually the model name, BGE small ENV 1.5 model name. This sentence transformer library, which is used for initialization of any kinds of pre-trained and language model or vision language model, then we'll be going to, this is actually object, this is actually class name. Then we'll be going to encode any kinds of input query. Query is what is embedding. Then we'll be going to print embedding data as well as dimension of the embedding output. The output dimension is 384. This is actually output of BGE small EMV 1.5 embedding output. This is actually high dimensional vector space, and this one is actually size of the embedding output. The architecture design choice when the model is being designed, like a distillate BERT or transformer. The final output layer configured to produce vectors of a specified size, like 384 in BGE small ENV 1.5. Now let us see, is this better embedding algorithm or poor embedding algorithm in terms of performance and accuracy? This choice is a trade-off between performance and accuracy. First, we'll be going to see about that performance. Like smaller embeddings, the output dimension is actually 384. This is actually smaller dimension when compared to clip embedding. Clip embedding dimension is actually 768 for both text and image. These are actually faster, which requires only less memory to load and then less memory to processing input text. Significant accuracy achieved by this small ENV 1.5 model. Larger embeddings can capture more nuanced information that is actually high level information. And the next we'll be going to see about that. Define the pooling layer embedding. Models often use mean pooling. Pooling is all about the average technique or CLS token pooling on top of the transformer layers. The output dimension of the transformer hidden states is usually passed directly to this layer. For BG small NV 1.5 model, this is set 384 dimension as the last projection layers of output, and the next one is training and optimization. During training, the model learns to represent sentence as a fixed size vectors. Fixed size vectors are both an input sentence will be converted to 384 dimension using contextual learning. This size keeps constant for all inputs regardless of sentence length. The dimension is part of the model learnable parameters and it remains the same throughout inference. Next, we will be going to compare embedding output dimension with the other models like the BERT base uncaged. The output dimension is actually 768. BGNV 1.5 model output dimension is actually 384. And then sentence T5 base output dimension is actually 768. And then all mini11 V6 V2 output dimension is 384. And then finally, summary of this tabular information. The embedding size is determined by the model architecture, its final output layer, designed as a balance between accuracy and efficiency, and then trained to produce fixed length vectors per any input query. And next, we'll be going to see about that what is FAISS. FAISS, which stands for Facebook AI Similarity Search, is an open source library which was developed by Facebook AI Research designed to efficiently search for similarity vectors. There's actually high dimensional dense vector embeddings in your large scale datasets. It is a crucial tool for tasks like semantic search and then recommender system, image similarity search, and then face recommendation kinds of application, and then retrieval augmentation generation. What problem does FAISS solve? Imagine you have millions of documents and then each is represented as a vector. Vector is all about small kinds of matrix embedding. Using a model like BGNV 1.5 model sentence board. Now, given a query vector, how do you quickly find the top k most similar vectors from this massive set? This is where FAISS shines. It allows for fast nearest neighbor search in high dimensional spaces, memory efficient indexing of huge datasets, million to billion of vectors, CPU and the GPU support for scalable performance. These are all the index will be used in the FAISS vector database as such. First one is the index flat IP. L2 is all about that Euclidean distance, and then index flat IP. IP is all about inner product, that is actually quotient similarity. And then index full flat, and then index HNSLW, hierarchical navigable small world graph, and then index product quantization. This is actually used for memory efficient compression and then fast search. Next, we'll be going to see about how FAISS works step by step. Embed your data, use model like BGE 1.5 model to convert each text chunks into vector. Then final outcome will be 384 dimensional floating point array. And then next we need to choose any kinds of index, add all vectors to FAISS index. You can choose flat or approximate indexing depending on your speed accuracy needs. Then we need to normalize our input query. For quotient similarity, you have to normalize the vector to unit length before indexing. Finally, we'll be going to make a search. When a user enter a query, you embed it, and then FAISS will be applied, and then returns the top k most similar vectors from the vector database, and their distance are IDs. Here, distance is all about a confidence score, how much, which is similar. And the next one is ID is all about index. And the next we'll be going to a small example with FAISS and BGE small EN15 model. And then first we'll go to initialization of 1010 and so on. BGE small NVN5 model. This is all about input documents. Paris is the capital of frames, and then cats are great pets and the machine learning is fun. And then we'll be going to convert our text into numerical model data and code. This is all about the document information. Convert into floating point 32. Then we'll be going to normalize it FAISS.normalize L2 and then FAISS.index flat IP, and then we need to add with index document embeddings index.add. Finally, we'll be going to make a Q input query. The input is tell me about France is a capital, and then query vector model data encode and then convert into floating pile 32, which is similar to all the documents data FAISS a normalize. Same thing also will be applied over here. And then top k is actually 2, you can also give 3. Distance is all about the confidence score between the input query and then document retrieve, and then index is all about index of the data, index search. We need to keep query vector and then top k. Finally, which will return our top k data, we need to edit using for loop for I in range top k. This is all about our document index data, then confidence score. And the next one is the FAISS example with the equally distance for BG small EN v1.4 model. And next, we need to change only index flat L2 instead of IP. And they needed to add then query and then query vector, then top k. Why use FAISS scales to billions of vector when using advanced indexes? Suppose a real-time search, especially with a GPU supports and then pluggable into NLP competition audio, anything with embeddings can store and load index to disk, local disk. These are all the use cases of FAISS, semantic search in PDF websites and chats, product recommendation, and that video recommendation engines. And then duplicate deductions such as the plagiarism or fraud deduction. And then it can be also used for images, if not a search or face recognition kinds of application. Next, we'll be going to see about small information. FAISS is developed by Facebook AI research team. Language supports Python and C++, and then speed very fast. And then accuracy adjustable at that via index choice. And then GPU supports like a coder. And then integration with the Hugging Face transformer and then sentence transformer licensed by MIT. Next, we'll be going to see about small information. Phi-2 model, the name is actually Phi-2. This was actually developed by Microsoft Research AIT and it was released in the year of 2023. This is actually transformer-based language model, and then model size is actually 2.7 billion parameters. And then training data, user high quality synthetic data, as well as a filter data set, like a text box. On reasoning and the Navy content main focus strong reasoning, a mathematical reasoning, code understanding, and then math kinds of tasks. Performance outperforms large models like Llama 2, Sound Billion in reasoning, as well as language task. And the next one is the licenses, all about research only, and then use cases retrieval, augmented generation, coding assistant, and then education tools. Again, fist link, and this one is GitHub. And they were released a lot of models in PI version like PI3, 3.5, and then 4, etc. Now we'll be going to see about that. What makes Phi-2 a special small about a powerful UH dispatch is ideally compact size. The size is actually 2.7 billion parameter PI. to achieve state-of-the-art of results on many benchmarks compared to much larger models like a Llama 2. Soundly focused on training, it was trainer primarily on filter synthetic datasets, emphasizing reasoning, logic, math, unlike a general web script, corpora, and then efficiency. Decelerator to be efficient, consumer grades GPU ideal for edge and low resource inference scenarios. Next, we will be going to see about that a Phi-2 explanation of the model. Phi-2 is actually lightweight and highly capable of model. This is actually language model developed by Microsoft's Azure team, released in the year of 2003, 2.7 billion parameters. Phi-2 demonstrate impressive performance after outperforming much large models such as Llama 27B, various reasoning tasks like coding, mathematical tasks, and etc. The standard characteristics of Phi-2 lies its training methodology. Rather than relying on large-scale, noisy web scroll of the corpora, it was trained on high-quality filter synthetic datasets. The datasets were designed with a focus on textbooks, logic, rhetoric problems, coding tasks, educational content, which provides the model with a more structured and understanding language, problem-solving typical large language models. Phi-2 is built on a TAMSUP-based decoder-only architecture, which contains only decoder network. Like GPT, which stands for Generative Pre-trained Transfer Mark, similar to GPT models. And it supports both type of learning, such as zero-shot learning and then few-shot learning task effectively. Thanks to its curated training approach, Phi-2 excels at the task requiring logical reasoning, mathematical computation, and then programming syntax understanding. And then making it particularly valuable for application, educational, automated tutoring, code generation. Furthermore, this small footprint makes it ideal for low-resource environments such as edge devices like Jetson, Raspberry Pi, and the next setup. Inference scenarios where memory and the latency are critical. Here I have given a PI to paper links, just you can go and read entire documents of link 1 or the link 2. Our next will be going to initialization of Microsoft Phi-2 model and then download from official Hugging This repository. First, we need to import to Torch and then transformers. Import auto model for a casual LM and then auto tokenization, and then we'll be going to set a CUDA here. Auto model for casual LM from pre-tuner, which is supposed to download model from Hugging Face repository. Torch type is actually auto test remote CUDA true, and then we'll be going to define also a tokenization model, a Microsoft PI to test remote CUDA true. And then this is all about a token is here. Model to generate. This is actually small output was generated by PI to model. This will be going to import FAISS NumPy and then sentence transformer and tokenizer auto model for casual. Then we'll be going to initialization of sentence somewhere as well as R2 topodize set auto model for casual LM. This is all about input data. Phi-2 is a small language model developed by Microsoft. It has a 2.7 billion parameter. Paris is the capital of France. 5 is a library developed by Facebook, a research team. And then BG small ENVN5 is an English sentence embedding model. Our next one, this is actually we'll be going to embed using our BG small ENB 1.5 model. Next, we'll be going to apply faces. Dot index flat, L2 is all about that, include distance. And the next we'll be going to, this is actually Query V is a developer, Phi-2. Next, we'll be going to convert text into word embedding. Embed model, I encode query data. Type is float32. Next, we'll be going to search for embedding and then documents. I retrieve the documents. Next, we'll be going to combine the sentence using for look. And then next, we will be going to prompt make. The following information has been retrieved and then based on the above answer question. This is all about input organization, convert into CUDA. This is about what will generate inputs. And then maximum number of tokens is all. Do sample and then pad tokenization, ID tokenization, dot end of sentence token and ID output 0 and then skip special tokens true and then generate text split. Answer finally. This is actually answer on Microsoft Research. Next, we'll be going to install 5C CPU sentence transformers and then accelerate and then PyMU PDF. Next, we will be going to import on a fix 5G stamp by sentence transformer auto tokenizer. Then we initialize the sentence transformer auto tokenizer auto model force cache on a log. This is the function which is supposed to extract text from PDF or any kinds of document. Then we'll be going to a page. Then we'll be going to a plus, but plus which is supposed to add data with this. And then finally, we'll be going to return a full text. Next, we'll be going to chunk text. This is actually function named chunk to text, which we need to feed over our document to this function. Next is all about chunk, size is all about 300, and then overlap is actually 50. 300 word combining is called list of chunk data. First, we need to split text split, which will convert into list data type. This actually chunks list will be going to iterate line of words. Line of words is all about total number of words in a document and then chunk size minus overlap. Word will be going to set index. Index is actually I and then I plus chunk size. We'll be going to write it and next we'll be going to append into chunks. Then finally we'll be going to return a chunks of data. Next we'll be going to initialization of embed model, encode, convert into our text to embedding vector, and then data type is actually is type at float 32. Then index plot L2. L2 is all about that equal distance. And then we'll be going to add, and then finally we're going to return index and the embedding chunks. Next, we'll be going to retrieve chance embedding encode and then index.charge. And then next, we'll be going to make a prompt and then context. This is all about context. This one is prompt tokenization and then model output generated by Phi-2. The maximum number of token is 100 sample is actually false. Finally, which will return generate a split answer. Space will be removed here, strip, and then we'll be going to import ways, which is the basic Python library, which is used to do a basis Python operation. And then google.colab files, which is used to upload files inside the folder content data files.upload. And next, we'll be going to get the current working directory. Current working directory is actually content. Next, we'll be going to access PDF files from a folder. The folder is actually data with help of a mutils paths, which is used to access images or paths from folder. And then PDF path files is content data transformer architecture.pdf. This is actually user query. Extracting text from PDF, extract PDF function, then chunk text, then build devices, and then retrieve chunks. Finally, we'll be going to generate answer with help of Phi-2 model. This is actually user query relevant chunks with end of faces. This is actually Fidel also.